how many distinct eigenvalues are there? Previously, how many non-zero eigenvalues? But now, how many distinct eigenvalues? So read the question carefully first. Read twice the question before marking the option. Okay, so 1, 1, 1, 1, all ones. Then generally, how will we find eigenvalues? What is the criterion? If this is given in the academics for 15 marks, don't apply this shortcut and don't teach. If you are teachers, don't teach this shortcut to your students. They have to do like that only. Like applying determinant A minus lambda equal to 0, solve it. Then fourth degree equation, you get solve it. Then you get 4 eigenvalues. That is the procedure. That is how they have to do. If you teach this shortcut, if they fail again, they will blame you and you will blame me for teaching this shortcut. So be careful. Don't teach this for academic students. That is, don't ask them to write in the SEM exam. So this is helpful in the entrance point. This is determinant A minus lambda equal to 0. But this is 4 by 4. That much space will not be there in the examination, and time of problem also will be there. So how we are going to handle is we require a shortcut. Some of you must be knowing. The shortcut is original method is in place of A, we have to write this lambda into I means identity matrix 4 by 4. Find out the characteristic equation. It is a 4 by 4 matrix. So you will get 4 eigenvalues. That is original method, correct. So, but because of time constraint, we need to look for a shortcut. Again, derivations you can derive or you can look into some text. Here, this is not the platform to learn how we got it. So I'll teach you only the shortcuts. So 1, 1, 1, 1, all ones are there. Then when all ones are there, there is one shortcut for finding eigenvalues. So what is the shortcut is, if it is an n by n matrix, all ones are there. Then eigenvalues are. What are the eigenvalues for this are? Because order is n, there will be n minus 1 eigenvalues will be zeros. N minus 1 values will be 0. And nth eigenvalue will be n. How many eigenvalues will be zeros? N minus 1 eigenvalues will be 0. So here n minus 1 and last one is n. So totally how many eigenvalues? N eigenvalues. This is lambda 1, lambda 2, lambda n minus 1. This is lambda n. N eigenvalues are there. So this is the shortcut when all ones are there. Now come back to our question. This is 4 by 4. N is 4. So what are the eigenvalues? Therefore, how many eigenvalues will be 0? 4 minus 1. 3 eigenvalues will be zeros. 0, 0, 0. 3 eigenvalues. And nth eigenvalue is n. What is n? Order of the matrix. Order of the matrix is 4. So how many eigenvalues? 0. 3 eigenvalues 0. 1 non-zero eigenvalue. So if you read the question as number of non-zero eigenvalues, how many non-zero are there? 1. So in that tension in the examination hall, so you may answer 1. First option is most dangerous. So if first option is correct, then you have to think twice, reread the question number of times and then mark. Because always tempting option will be kept as the first option. Tempting option. So you will be tempted by looking at the answer and you mark. So you should be very careful. First option correct means you are walking on the smooth surface. Smooth surface means you will fall down if you walk fastly. So you should be very, very careful. So similarly, first option, because now previously what did we answer? How many non-zero eigenvalues? Here also how many non-zero eigenvalues are there? This 4 is non-zero eigenvalue. This is the only non-zero eigenvalue. So you may answer 1. If the question is number of non-zero eigenvalues, answer would have been 1. But you are not asked to find how many non-zero eigenvalues. But look at the question, number of distinct eigenvalues. How many eigenvalues are there means, how many are there? 4. Because it is 4 by 4, 4. How many zeros are there? 3. How many non-zero are there? 1. But how many distinct means? 1 eigenvalue is 0, 1 eigenvalue is 4. These two are the distinct eigenvalues. 0 is not equal to 4. So remaining are equal to 0. They are the same repeated eigenvalue. So this, how many are repeated? 0 is repeated 3 times. And 4 is not repeating. So what are the distinct eigenvalues? 0, 4. How many are there distinct? 2. So answer is 2. So in order to answer this question, we need to first know the shortcut and apply the shortcut. All ones are there means apply the shortcut. How many 0 eigenvalues will be there? N minus 1 zeros will be there. Nth eigenvalue will be equal to order of the matrix. So there will be 3 zeros and 4th eigenvalue is 4. How many? Non-zero means 1. Same question this time. This time you may find the same question. By looking at the question, don't mark 2. Read the question. Question may be given in different formats. Wantedly sometimes same question will be given. Because students will look at only matrix. They don't read the what is the matter, what you are asked to find. Because in the happiness that you found one question which is known to you, you start answering whatever you have learned in the class. So today I am saying 2. If you memorize and go 2 and again mark, again don't blame me later. So read the question carefully. So same question may be given with a different matter. What you are asked to find may be different. So read the question carefully.
Madam,
so how many times? Yeah.
Question manna DL JL అడిగాడు మేడం గురుకులాలలో rank of this matrix అని అడిగాడు మేడం సేమ్ క్వశ్చన్.
Rank of this matrix. Rank ఏమవుతుంది? What is the rank of this matrix?
చెప్పండి ఎవరైనా చూద్దాం. ఎవరైనా anybody respond?
Anybody? Can you?
మేడం కొంచెం తెలుగు కూడా వాడండి మేడం.
Okay, okay. నా ఇంగ్లీష్
one madam.
One sir.
One.
That is one. Question అడిగాడండి DL JL రాసిన వాళ్ళకి గుర్తుంటుంది అనుకుంటాను. Rank of this matrix అడిగాడు.
How did you get 1? That is R2 minus R1, R3 minus R1, R4 minus R1.
Row echelon form, ma'am. If you apply row echelon form, we'll get all
Row
the
echelon. 1, 1, 1, 1.
Or can use
all zeros.
determinants also.
So how many non-zero rows? Determinant is lengthy. So better is echelon form because the maximum zeros are there. How many non-zero rows are there now? Only 1 non-zero row. So rank is 1. So if you learn this and 1 and go to the exam, then 1 will be the first option. And again, if you learn what I said now, how many non-zero distinct eigenvalues, 2 is the right option. Same options will be given. This matrix also will be same. But what you will be asked to find will be different. Next time when you go, they may ask you what is the sum of the eigenvalues, or what is the determinant of this? What is the product of the eigenvalues? What is the product of the eigenvalues? Determinant. You know the relation. Determinant is nothing but 0. Why 0? Property of determinant. If any 2 rows are identically same, determinant is 0. So product of eigenvalues is nothing but, even you need not do this much also. They are asked to find what is product of the eigenvalues. What is product of the eigenvalues? Determinant. What is the relation between eigenvalues and determinant? Product of the eigenvalues is equal to determinant. So determinant is 0. By looking at the question, by looking at this matrix itself, you can say, because 2 rows are identically same, determinant is 0. So what is product of eigenvalues? Automatically 0. You need not find eigenvalues and find the product. By looking at this, you'll be able to say. Similarly, what is sum of the eigenvalues? It is nothing but equal to, any one of you know? What is sum of the eigenvalues?
Trace of A. Sum of the
Trace of A, correct, good. Correct, excellent. Trace of A. What is trace of the matrix? Sum of the principal diagonal.
principal diagonal.
So what is the principal diagonal here? This, when you take ones, this A11, A12, this is principal diagonal. Here for 4 by 4, this is the principal diagonal. I'm spoiling the question. So this is the 1, 1, 1, 1. So 4 ones are there. 1 plus 1 plus 1 plus 1, 4. So what is sum of the eigenvalues? Is equal to trace A. What is trace? Sum of the principal diagonal elements. What are principal diagonal elements? 1, 1, 1, 1. Add them. So you will get trace A. 1 plus 1 plus 1 plus 1. That is nothing but sum of eigenvalues. So sum of eigenvalues is 4. Product of eigenvalues is 0. You need not even apply this shortcut. You need not find eigenvalues and add them. But you can apply this shortcut. So again, same question may be given. Like how many non-zero eigenvalues are there? How many non-zero eigenvalues are there? There are 4 eigenvalues, 3 are zeros, only 1. So
Only
1 is the correct answer. So using same question, using the same matrix, you will get like different questions. One matrix has given rise to know how many questions you can see. 5 different questions, 5 to 6 questions we can create. Is that not? So be careful. Don't look at only matrix. By looking at the matrix, you feel so happy. Abba, this we have done in the class. So directly from the notes you got. Remember, no question repeats in the exam because whenever paper setters are there, they'll be given instruction. If they are setting the paper for the SEM exam, instructions will be different. If they are setting the paper for the entrance exam, instructions will be different. Instruction will be no question should repeat from the previous paper. Then why we should solve previous papers? Just to make our mind sharp. With the sharp mind, you can attempt anything. Is it not? You can cut anything if the is it not? If the knife is sharp, to make the knife sharp, our effort is required. Similarly, to sharpen your mind, we need to answer previous papers. So you will come to know what are the different ways of asking the question. So you will have that like a motto to think in that channel. So your mind will become sharp. You can answer any question based on that. Okay. So this is the way. Any doubts? Shall I go to the next question?
Yes, sir.
Emma?
Yes,
Yeah.
ma'am.
So this is known to you. You know
Yes,
eigenvalues, you know sum of eigenvalues, you know trace, you know everything. But you should be able to apply in the exam. That is